Hello and welcome to part 4, I think. So the goal for this video, I think the goal for this video is to be able to push the actual arguments for the main function into our main function, so that we later can access them. I don't know if we're going to make it possible to access them in this video, we'll see. But let's actually fix one thing first. So argc produces this assembly file here. I'm just going to make a txt version of it as well, because my editor doesn't like to show .s files for some reason. So if we do that, why am I not seeing? I'm not seeing that either. Oh, I know why. Why did I do that? Okay, we wanted this. So now if we go, I'm still not seeing that. Why aren't you creating that file? Oh, I know why. I ran the wrong binary. Oh well. So now we should see this. So this is basically the assembly that's being generated right now. So we need to push the arguments into our into the stack so that our main function can access it. So how are we going to do that? Well, we could just access it directly from the stack pointer inside of our main method. But since we want to have a generic approach for each function, we should probably push it to the stack using the C call. I don't remember the name of it. C call, some standard C function argument implementation thing. I don't remember the name of it. But basically what we want to do is, let's just say if I can make this assembly do that, if I remember how to do this. As I've told you before, I'm not really an expert on assembly. I'm a noob when it comes to assembly. And we're actually doing 32-bit assembly here. We will probably do 64-bit later, but 32-bit is the assembly that I'm currently more familiar with. So we're gonna do 32-bit first. Okay, so we're moving the EX into EBX, because here we are doing the exit. So before we call the main, we want to push the arguments to the stack. So basically, I think we can do push, and I think we can do EBP, ESP. I wonder if it's ESP. So argc. What if we, let's just try and do something here. So what if we, instead of moving 16 into EX, we're going to move -4 minus 4 ESP into EX, and let's just do and let's do an AS AS main.s main.o LD main.o main. No, that's not how you do it. Is it for ESP? So ESP. No, wait, isn't it EBP? Oh wait, I think one problem here is, no, I don't remember. I'm gonna have to look at some notes that I have. So if we do, I think it's in chapter EP contains pointer to the top of the stack. What if we go to, and we have a look at this one, and we can see here that argc is 0. Okay, so okay, EBP. So actually EBP was correct, but we don't need to, we only need to do that, I think. Okay, let's, I don't know, we can keep it there, I guess. So if we do run this, still getting a seg fault. Why is that happening? Jesus. So, for name of the program, number of arguments. These are just some notes that I have. EBX, put file name to EBX. So what's actually happening here when we're doing EBP. So EBP, put file name into EBX, EBP. EBP. So we shouldn't need to do oh wait, I'm actually modifying the wrong source file. Oh. So we want to do EBP, and let's do 0 just to be I don't think we need to do 0, but who cares? So that still didn't work. So that's still not working. Oh, wait. What? How is this? How did this program ever work? So it's not really doing what I wanted to do. It's the EBP. Maybe the EBP. Maybe it's actually at 4 bytes down because we're inside of this function. No. I don't get that. So let's just put this back. So if we do that, let's just move 2 in there. We're getting 2. Good. So now if we instead of here that we're going to do EBP. EBP. Okay, we're gonna do some Googling. So ESP should be ESP then, I guess, but why is it not working? Should be ESP. X. What if we move that seems really weird. What? Oh, that's strange. Okay, so what if we don't do U, and we do EVP. I don't know, it doesn't make sense to me. It doesn't really make sense to me. Maybe X colon. O2 X. Zero ESP. Oh wait, maybe it's actually happening after. So like, no. So there we're getting a seg fault, but if we do this here, if we do that here, oh, that's still. Let's clean it up a little bit. So let's remove that, remove that. Oh, we wanted to. And Okay, so here's the problem. I was basically executing this using the wrong, because we're doing 32-bit, so we have to use 32-bit, of course. So what we're going to do is going to this one, and we're going to add these flags here. So and there we go. And I also noticed that I had some problems here, because I don't even know how this ever worked. So now if we can remove that test directory actually, or maybe let's remove a test. So now if we do that and we execute, we're still getting that result, which is good. So what we want to do now is actually so let's make that test directory again actually, and we're going to copy in the a.s.txt in here as main.s, and we're going to modify this a little bit just to try things out. So what we want to do is right here we want to push, and we want to push this one into, we want to do that, okay? And don't worry about that errors, because it thinks I'm doing 64-bit. So if we do that and we go into the test again and we do this and we do an LD, we're getting that, which is cool. But so once we have done that, we actually want to add, we want to add 4 to EBP. I think we want to add 4 to EBP to restore the base pointer, afterwards. And then we want to here we want to do move. We want to push EBP, and we want to move ESP into EBP. Okay, I think that's what we want to do. And then to get the argc, we can do pop into ECX, I think. And then if we move ECX into EX, segfault. So isn't that because we also need to pop into EBP? I think I have to look at my notes here again. So if I go to chapter 4, first of all, this should be ESP. Or actually, do we really want to do that for the main method? I don't think we need to do that. I don't think we need to do that. Push. Or actually we do, because we're pushing this to the stack. But the stack already contains it. The stack already contains these values, so it doesn't really make sense to push it again, but we're doing this in a generic approach, so that's why we're doing it. And then we're going to EBP, move ESP into EBP, that's correct. Pop EBP, okay, so actually maybe that's, now we're still not very happy. So that's because why am I doing the pop here? That's because we need to use EBP because this is at the 8th position of the stack. Why are you angry though? ESP to EBP. Push EBP. Wait, no, sorry. Move EBP into ESP, push EBP, pop EBP. So what's going on? We're pushing the argc to the stack. Okay. And we're calling the main. So why is that not working? EXMX main push. Move ESP to EBP. Move EBP EX. Popple. So yeah, okay. So the reason why it's at number 8 is because shouldn't it be at number 4 actually? No, because we have the return address, so the return address is going to be there. What if we do 4? So you're actually still angry with me. And one reason why it's angry is because we should have done that. So now we're getting that 4, but we want to use EBP. Which gives us a 1. Okay. If I do... Okay, so now we got it working. Cool. So basically what we want to do in our assembly front end is basically when I drink some coffee, so before we call main, we need to give it its arguments. So basically we're going to give you zero ESP. We're going to give you 0 ESP. That's the argc. And then when we're done calling you, we need to reset the pointer. So we're going to do add 4 into ESP. And if we go and ESP is the pointer to the top of the stack. So, and the stack grows downward. So when we're adding this this value to the stack, the address actually gets smaller. So when we add 4 to it, it's going to go back to the old size, basically. Okay. So now the main function should have all of that stuff. But now when we visit a so here when we're doing a function, we also need to push, was it EBP? Push EBP, because we need to store it. Oh, let's just not take any chances here. Yeah, we're pushing EBP, and then we need to move ESP into EBP so that becomes our base pointer. Okay. And now basically this is the argc thing. But since we're not really we need to do a template end is equal to move EBP, what was it? Yeah, move EBP to ESP. And then we need to pop EBP So what if, we're going to encounter a return? Maybe this should actually be maybe this should actually be down here. Yeah, I think that makes sense. So let's get this one, and we're gonna put it here. Like that. Invalid character. So we're getting multiple. So that seems to be working. Now obviously it's still returning 16, and we cannot really return argc to see that it works because it doesn't know what to do with it. So like if we compile this, it actually compiles. But it's going to basically, it doesn't know what to do with that. So so in our assembly front, I think we're going to encounter this variable here. No, we're not. That's pretty weird. So compound. Oh wait, maybe the parser doesn't know what to do. Parse expression token ID, token parse ID. We are encountering the argc. And then we're encountering a call. And the value of the call is that. Oh, wait. No, we're not going to end up there. So we're encountering an argc with the value of 5, okay. But why isn't the from encountering it? Step variable. Should be encountering it here. Or is it because, no, I don't know. Oh wait, I know. So we're only, no, I don't know why that's happening. So let's print the child type here, I guess. Printf. No, wait. Inside our call. So we're doing a call, right? We're doing a call. And we're not really first arg int value. Okay, so we're always checking for the int value of this thing, but if it's a, we don't know the int value of it if it's, so okay. I see the problem here. I do see the problem here. So we're going to push the int value, which is going to be 0, right? So this is returning a 0. Okay, so that makes sense. But basically we're going to have to look up the argc. So how can we do this? How can we do that in a nice way? So I think when we do a call, we should map up the arguments. First arg, okay, first arg. So one way we can do it is inside of our parser, maybe we can put identifiers on these arguments. So when we parse a list, like for each thing we put in the list, we could put an identifier on it so that we know where in the signature it is. Or should the front end handle that? Maybe the front end should handle that. So okay, let's do it like this. So here we're going to have a unsigned, no, int ID, and we're going to do const chart template is equal to this. So basically, if ast type is equal to ast int, then we're going to do this, and we're going to do a char s is equal to calloc string length template, and let's just add some bytes, size of char, and we're going to do a string sprint f to s with template, and we're going to put in the ast int value. Okay. Otherwise, we're going to do a other thing. We're going to do sort of this as well, but we're going to do a digit with is p instead, and the digit, let's just only add 4 here or something, 8 maybe, and the digit will be the ID. Maybe we should do rs equal to size of char, and we're going to do a alloc Okay. And finally, we're going to return s. So then we can do char char var s is equal to calloc1 size of char, maybe, or actually, yeah, let's do that. And then we're going to do a actually, let's do a 2. Now let's do a 3, and by default, just going to be 0 is going to be that, and rs1 is going to be 0, and bar s2 is going to be that. And then we're going to do if first arg var s is equal to realloc var s char var s is equal to asf first arg sterling as var s plus 1 times the size of shard. And then we're going to, I think that's it actually. And then we can actually free as var s before or after we do this. So then we're going to make a string here instead, so we're going to do that, and we're going to do var s f variable, and okay, so we actually need to specify and you're going to be 0. So here we're moving ESP into EX. No, the pop comes in the wrong order. Pop. Or is it pop? We want that move to happen. We want the move to happen Move pop EBP. No, this isn't right. We want that move to happen before we reset the thing, so something is not right here. Oh. EBP, move EBP, ESP. So I think we just want that to happen here, I guess. Let's just see if it works. Does not seem to work. So what's the problem? We're pushing 0 into ESP. We're calling main, resetting it. Removing 0 into X, move EBP, X. So the one I wrote, what's the difference? Push, call main, add 4 ESP, move EX into EBX. That's right. Push EBP, move ESP into EBP. Move 8. Wait. What? 8. Oh, that was because we had the... Okay, so it was because we had the... We're using the wrong stack location. So like here, of course, here it's going to be 0. But now it's like in our custom stack here, over here. So we need to like, it's in our new stack frame, so we need to use that one, I guess. So in our front end, like when we make a call, we actually have to the first argument in our stack is going to be at location 8. I'm just gonna see if I have documented this somewhere. Yeah, so it should be at 8. So now if we compile, it still doesn't work. No, because why is it not working? Why are we not getting the 8 here? Oh, we're never entering this? That's pretty weird. So we're not getting a first variable. Okay. But we are encountering a call, right? And we're ending up here. No? What? Oh god, I'm running the wrong binary again. Jesus. Now we're getting it. Okay, so now if we run... Cool, so now we can access it. So now our assembly looks like... what did I do? Now our assembly looks like this. Cool. Cool, cool, cool. So now we can access argc. That's pretty cool. Now, if we want to be able to access the arguments as well, so for example, what if we wanted to, if I ran this and I entered like hello, obviously we're going to get arguments of size. argc is going to be the size of 2 because the first argument is the name of the program, and then here is the hello. So maybe we want to access these arguments as well. And for that we would need something like, I don't know, we would need something like this. And maybe we want to access this one, which would be the hello. I don't even know what, yeah, it's not gonna know what to do with that right now. So, but we need to implement that kind of syntax to access the elements in there. So where we would start doing that is actually in the Lexer, because we don't have support for that yet. So actually we would start in the token, and we would have a token L bracket, token R bracket, and then in our Lexer we're going to add, actually let's add it here, left bracket, and we're going to have a right bracket. So now if we do that, the parser doesn't know what to do with that. But basically, if I think this syntax is also going to work, like you can do like that. It's going to think that it's a function call, and it will actually compile it. If we look at the assembly, it's probably not going to make any sense. I don't even know what it's going to do with that. It's probably not going to do anything with it. Call main. I would have actually guessed that it would have called like call main. So shouldn't it try to call oh, it's only going to oh, I see. But anyway, I don't think we want that kind of syntax. I don't know. I think it's better to do it like that. And then in our parser, we're going to actually treat this as a list, I think. So basically, this bracket is equal to parser token type is equal to token bracket. Then we can do is bracket token bracket. Otherwise this. Why are you angry? Oh. And then we're going to do here as well. Is bracket token right bracket. Otherwise that. It's not really going to help us right now though, but what we can do is when we're parsing an ID, we can do a else if parser token type is equal to token bracket. We're going to call this no, actually, I don't know if I know that I'm going to want to move this away from here later, because if I put it here, it's not going to enable us to do things like this. Because it's not a recursive parse thing here. But let's just do that for now, and we can make it recursive later. Because when we implement the math stuff, we're going to implement like factors and things. Or what do you call them? I don't remember the name of it. Anyway, so let's call this AST what are we going to call it? AST axis. I don't know, AST. Let's just call it axis for now. And we're going to do a est.h, and we're going to do a AST axis. And the value is going to be parser parse list parser. And now it doesn't know what to do with that. So basically we would do a st access is equal to astf access. And then we would do a char now. I don't really know how we're gonna deal with this though. The access thing probably needs to tell us where, like, we need to know what are we trying to access and where does that address start at. Which is difficult, of course, because if we're in the main method there, then like we're trying to access something from the stack here, right? We're trying to access something from the stack. So we need to know where argv is. And what is argv in this case? Well, the argv, I feel like I'm missing depth to the front end here, because we don't really have any context here of where this access is coming from. Like, we need some sort of context object to pass around to know where it is coming from, because if it's coming from where are we here? Where are we? So if it's coming from a function, we need to know that it's coming from a function and which argument it's coming from. So, like, when we're visiting a compound, okay, this is difficult. When we are visiting a compound, when we're visiting a compound, like, where are you? And where should we look for things? Let's just see if we actually end up here. So yeah, we're ending up there. First of all, the thing we're accessing, actually we can copy this from here. So if we do that, and we do printf, no? Error, invalid type of have int. Oh. So we're getting that, and I think this is going to have a int value, because we're trying to access something. Yeah, so we're trying to access number 1. So right now we don't really know what to do with that. So what if we call every method with an argc in the beginning, then we can just always assume that I don't know. Anyway, we can't do anything here right now. Let's just I don't know. Let's just return an empty string for now, because we won't actually be able to access that quite yet. We also need to push those arguments. So basically we also need to push I wonder if we can push, what if we push if we push 4, but if we push it, can we push that like in an indirect mode? Like I want to push the address of it. So if we push 4, that's actually going to give us the value, but if we do, I don't know, it's possible to like do that. No, it doesn't know what to do with that. SP. What? How is that a problem though? So this will be the name of the program. If we run this now, still works. Cool. So what if we do this? If we move a.s to main.s, so we're gonna need to add actually 6 here. No, 8. Need to add 8. And then that's going to contain the name of the program. So now if we do 12 here, it's going to put that name of the program as a return, but obviously we cannot return a list of bytes like that. Wait, how does that work? Oh wait, I'm running ASLD. What? How does that even work? Wait, maybe it's actually at the... Wait, is it at minus? -4? So the way it was before was that. So now we're getting something more strange. So main, what if we move like I want to use possible to do this, so no speed. What if we move you to ECX, or yeah, and then we move ECX 1 into EX. Wait, got 0. Okay, got 0. Let's read here. Move B. Oh, we want to do move B. Oh, that's not really going to work. I don't think we can do that. No. No, I don't even remember what I was trying to do. Right, because we're pushing that argument. Yeah, I think I have to think about that for a little bit. But anyway, what we managed to do today is we made it possible to access argc at least, so that's one achievement. So now if we run this program, if we compile that, we get this binary, and we can give some arguments. So 1, 2, 3, 4, 5, and we're getting 5. So that's good. So now we can access the first argument of the main function. So that's pretty cool. But that's it for this video, and I'll see you in the next one.